Okay, so this lesson is on evaluating functions and inverses of functions from graphs. So the first thing I want you to do is take a look at some of these that are very easy, like this problem, that problem, and that problem. I would consider those to be very, very easy at this point in your life, mostly because we've been evaluating functions for a while. I'll just put the answers down, right? This one's 1. This one is -3. This one down here is 0. This is -4. And this one's 3. Okay, I'm not going to review how to do those because I know you know how to read this graph. What I really want you to focus on, though, is this. That's not the right pen. Let's try this again. Let's focus on this problem. Okay, so this is actually asking you not for the in or the output, but if you know what the output is, what was the input? So instead of giving you an X value, what that notation is telling you is, hey, if -3 came out, if -3 was the Y value, then what was the X value that you got or that you plugged in to get that? Right? So it's not giving you the input, it's giving you the output. So the answer to this particular problem is -1. Okay, let's try another one. I'll switch colors for you. Let's try green. Okay, so let's try this one. I hope I have a green highlighter. Yes, I do. Okay, so this is asking you, in English, it's saying if -4 is the Y value, right? So here's -4 is the Y value. The question is, what was the X value? So you can kind of see right here that X value should be -2. Okay, so let's try another one. Let me switch colors. Let's try red. All right, so for this one, this is saying if 0 was the output, if 0 is the Y value, then what is the X value? And on this one, it ends up being the same. It ends up being 0. All right, so that's what that notation is telling you or asking you. It's asking if 1 came out like here, right? If the 1 is the Y value, then what is the X value? In this case, that would be 3. Okay, so let's move this up. Okay, so now we've got these two different functions, right? And I cannot get that to stay there. It's as good as it's going to get. Okay, so I've got an F function, I've got a G function. I'm not going to do all of these, and the reason is I think like this one right here is easy. I think that one's easy as well. So let's start with the third one. So this is asking you, in the F function, when the output is -2, right? Here's -2 as an output, right? It's a -2 Y value. Then it's asking what was the X value, which would be 0. Excuse me. All right, so let's take a look at this problem. Let me switch colors. Let's go with black. Because this is saying, in the G function, if -3 was the output, which happens here, right? If -3 is the output, what was the input, which is -4? All right, let's take a look. We've already done composition of functions, so I'm going to kind of skip that one and that one. But this one, this is an important problem. So this is asking if the function is evaluated at 2. If F is evaluated at 2. Let me get rid of some of this stuff real quick. Hold on. Okay. So the function evaluated at 2 is here. So that's a -3. Then it's asking, all right, go to the other function, go to the G function, and the output is -3 right here. So what was the input? That was -4. Okay, and then this last problem, I'll switch to blue. So first thing, if I go to the G function and -3 was the output, it's the exact same one we just did almost. Now it's saying, all right, so what is the input on the F function to give you -4 to come out? Here's -4. 1, 2, 3. Yep, that's 4. So the input there must have been +3.